Hello and welcome. This is the QA and automation talk, also known as the QA for indies. We will talk about how to use QA practices and automated testing to make better games and do it for less money. So that's it. And the goal is to help indie teams and teams without a lot of resources to use these tools without spending a lot of resources, basically. So that's it. We will talk about first how QA works, like basically what's the QA role and the objectives, what kind of tools we have and how to use them in our team. We will also talk about how to write automated tests, and for that I will share some different test types and basically how to choose them based on what issues to find. And also, lastly, we will talk about how to automate. So it would be more on a theoretical level because I don't have a lot of time and I have a lot of things to say. So that's it. But first of all, who am I? My name is Nepo, and I'm tackling the elephant in the room. Why should you listen to anything that I have to say, right? So I've been working as a QA for a long time. And basically what I'm doing right now is I'm just going to take a breath. So what I'm doing right now is sharing what I've learned in generally software, like working on mobile applications and backend development and stuff like that, with people that are working on video games. So what I'm doing is writing blog posts and helping with incubation projects and stuff like that. And I'm also working as in Nocorpo, which is a very small team. We are just 3 people working with Godot and other open source tools. If you need help with anything on the talk here, or we're also up for hire. So if you need someone to make a game, just get in contact. But yeah, just without any further ado, let's go into the content of the talk. So the first thing that we need to talk about is that what does QA actually mean? Because usually we use it as a synonym for testing. So I'm going to do the QA for my game. I'm going to do the testing for my game. And that is not exactly true because the testing is quality control, which is just one of the many tools that QA has, right? So QA actually means quality assurance, and it's more of a set of a mindset, a work philosophy. So while quality controls checks the game that we build is correct, is good enough for the players, what QA does is we build tools and processes to kind of ease development, to make sure that we can build this game and release it with a good enough quality. So if QA means quality assurance, how do we ensure this quality? Let's see with an example. This is basically the life cycle for a project. We go from the ideation to production and then to the release of the game. So traditionally, QA is thought to happen at the end of the life cycle, basically. But this is a model that we have to get out of our heads. And in reality, QA works on processes throughout the entire development process, throughout the entire life cycle of the game. So I will explain this in more detail a little bit later, but first we need to understand the role of QA. And for that, we need to understand its goal. And you might say that the goal is to find bugs, right? But we can dig a bit deeper and just checking this, you can see that there's a point in this life cycle where it's different. If you find a bug there, it's going to be different after the release because it affects real players, right? So that means that they can give a bad review or it can have a bad publicity, and that affects the sales that you're going to make. Maybe people would even refund your game. So you could say that the objective for QA is finding bugs before the release, which, okay, technically true, but we can still dig a little bit deeper. So why don't we want to find problems at the end? In part because of the impact to the players that I just mentioned, but also because it implies a lot of work. So if we think about the user reporting a bug, and then we have to kind of prioritize the ticket and investigate what went wrong and work on the fix, and then we need to test it and build a new version, upload it, and the user has to download the game again, and then play it and report the bug if it's still happening, right? So this is what we call a feedback loop. And in this case, it's very long. This is a problem. So the thing is that we can make it shorter so that we can iterate faster on this problem. And the good thing is that we can still make it like shorter and shorter until we find problems while we are making the changes, right? So you can imagine this like you're making a change on the code, you write a new line of code, and that breaks another system, and you have something on your project that tells you, hey, you just broke this, right? So, and like and also like the best part about this is that we can even find stuff earlier, like while we are designing our systems. So like you can imagine like if you're in a meeting, you could say like, we are not going to work on this like this. We're not going to build this mechanic like this because it's going to impact this other system, and then we're going to have a problem. So then like finally we have the objective for QA, like finding bugs as soon as possible. Why? Because we can iterate faster on the problems, and we are going to do less work and make a better game, basically. This is called shift left testing, which is something that's more popular on generally software development now, and like for 10 years already, I think. And the idea is like not having the testing and the quality happen at the end of this process. It's like distributing it along the process itself. So yeah, so this is an example from a GDC talk by the developers of Sea of Thieves, where you can see how they use automated testing. The vertical axis represents the number of bugs, and the horizontal axis is just the months in development for the game. And the white line represents one of the projects where they didn't use automated testing and good QA practices, while the yellow one did use those things like automated testing and QA. And the thing is that you can see that for the white project, the number of bugs keeps increasing and increasing and increasing, and then has like a dramatic drop. While for the Sea of Thieves, it just stays in a manageable number. So okay, so you can imagine that working on these two projects might have felt very differently. Like if you've ever worked on a project that has a lot of bugs and it's very like difficult to iterate, that's what the white line looks like in reality. And also like this huge drop that you can see on the right, it's not something that happens magically. This is made with crunch, okay? So by applying like automated tests and good QA practices, you can kind of like alleviate, mitigate, maybe even completely avoid crunch. So it's a good thing to invest in. Okay, earlier I said that we'll explain what processes throughout the project mean, right? So what is a process? Is it something of this here? Some of those are processes. The thing is that I wanted to provide a definition for this. And so here's like a very big one. It's a series of tasks performed in order to achieve a goal. Because you can imagine like if you, like an example is making code or art for the game and then integrating it in the project, because it's not the same as like if you have a script on a folder that is not doing anything on the game. Yeah, you wrote code, but it's not doing anything for the game. So you need to integrate it. That's important. And like maybe even like uploading a build to Steam and then releasing it, or having a meeting is also a process if you want to make a decision, or like if you want to brainstorm to find new ideas. So QA works on these processes, and that's a beautiful idea, but how do you even test this? Can a process be tested? Can you test a meeting? And yes, you can do that. I'm going to share my two favorite meetings, which are the postmortem. That's the first one. And you can see that here we have 3 columns where we have like what went well, what didn't go well, and how we'll adjust in the future. So basically what we are doing here is we try to visualize the things that went well, basically the good things, and then try to make changes to make those things more common, or like make them better somehow. And then we also share the bad things and try to mitigate those. So like try to avoid the mistakes that we made, right? And the postmortem happens basically at the end of something. So it could be at the end of a vertical slice, after the release of a game, maybe after you finished implementing a mechanic. The retrospective happens more regularly. It's basically like you can have it like every 2 weeks or every month, or however long you define. Basically, it's the same thing. You have the good column, the bad column, and then agreements and actions for changes that you want to make. So it's basically the same idea. And I said, can you test the meeting? And the answer is that yes, you can do that. I want to call attention to this like bottom right corner here. And this is basically just a space to leave feedback after the meeting. You can say if you liked it, if you didn't like it, and then leave like more concrete examples of why, right? So in this example, it's just basically that the meeting was too long. Sorry for the Spanish. My team works in Spanish, so that's the only example I have. And basically, so the meeting was too long. What we did was, for the next meeting, we just got a timer, and we set a timer for 5 minutes whenever we started talking about a topic. And when the timer ran out, we decided, do we want to continue talking about this or not? And if we didn't, we moved on to the next topic. So yeah, like this is the general framework for this. You just look back on the thing and you notice the good and the bad and try to make changes to improve the situation somehow. And with this, we keep iterating, and this unlocks continuous improvement. So does this work? Yeah, like this is a stupid example, but you can see that even for a meeting like a brainstorming can make a difference. Like for the first project, we had we needed 6 hours along 2 weeks to decide on what project we wanted to make, because we had no guide, no structure. And then we got together for the postmortem, and we said, okay, what can we do to fix this? We made some proposals basically, and we split the meeting in two. So first we come up with ideas, and we prepare like a list of categories that we want to propose ideas for, and then we try to get to define a high-level game from the ideas proposed there. And with this, we made the choice in a single day, in 2 hours. So it's a huge improvement for our team. Notice that we were just talking about how we organize ourselves and how we communicate. And this is very important. I've seen a lot of teams fail because of this, because they don't know how to work together. And there's this concept of the Conway's law, which states that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. What does this mean? It basically means that if you have a team that works together, the end game is going to be like more cohesive than if everyone is working on their own silo, where everything is going to feel like more separate, like less cohesive. Okay. So a quick summary of what we learned here. We learned that QA can be applied throughout all the development process. We learned that the objective is to find and prevent defects as soon as possible. We do that by reducing feedback loops. And in order to reduce feedback loops, we can apply this framework of looking back, noticing the good, the bad, and then proposing things to change to improve the situation, right? So now that we know how QA works and basically what's the objective, we can talk about the tools that we have. And one of the most important ones is automated testing. So you might not know, it's okay. The pyramid testing model. So this is basically a model that splits the different kind of tests that you can write into these 3 slots. The unit test basically is a test that exercises, so it's testing the smallest part of the of your project. It can be a function, it can be a class, it can even be a node, and it tests that on isolation. The integration test gathers 2 or more of those units and tests them together. And then the end-to-end, or also called system test, tests the whole game. So like running as the final version, like a player would. The problem with this model is that it's super old. It's more than 20 years old, and you can imagine that things have changed a lot since it was first proposed. And it also smells a little bit like waterfall. There's this small top with end-to-end test, which usually gets replaced with manual testing at the end of the process, and that is something that we're trying to avoid, right, with a traditional quality model. And also it has a very big unit test base, which it doesn't make a lot of sense when you think about it. What is recommended right now is writing mostly integration tests. So we have this small phrase here that summarizes this very well. You should write tests, not too many, and mostly integration, by Guillermo Rauch. And there's these 2 models. They can each be used for separate things. I particularly like the trophy one, the one on the left, and then we also have the honeycomb model. And why should we write integration test? Basically, if you think about when was the last time that you wrote a single unit of code, like something that works like a pure function that has an input, and every time that you send the same input, you're gonna receive the same output, like a sum function or something like that. We usually don't work like that. Like in reality, our code is integrated with engines and libraries, and those have states. And that state is going to affect the output of our system, right? And it's also going to generate changes on that state. So it's a whole thing. And what this means is that if we don't test the whole thing, we cannot ensure that it works correctly. We need to test everything in its context. So we have to write integration tests. Sorry. We can do this with this structure here. This comes from behavior-driven development scenarios, basically given when then. So for the given, you set up the units that you want to test. Then on the when you act on one of those units, I always try to like make people make one action for the test. You can do more, but then it gets complicated, so try to keep it small. And on the then, you just check that this context, that the system changed as you expected. How does this look in Godot? It's basically like you prepare a scene, you call a method, and you perform assertions on the nodes on the scene. This is a code example. It's like the simplest example that you can make, probably. You just instantiate a scene, and you try to find a node, and then you assert that the reference is not null, so that the node exists. This is just basically testing that a test machine exists on one of our scenes, basically, on the player. And this can be more complex. Like this can become something like this, which is kind of crazy. But even with this is like probably one of the most complex tests that we have. And it's testing like a part of the safe system. So it has references to files. It has to manage like the create and delete those temporary files, and like it has reference to other systems. It's very complex. But even then, even with this complexity, it still has these three separate parts, like the given, when, then, with a single action on the when. This is well, when it loads, we have an example here. Okay, there's a video, I promise. Let me check. Oh, finally. So this is one of the games that we made in the team. It's called Meatball. And when we wrote the test for this game, we hadn't prepared the project to accept tests. But basically, you can see. Let's see if I can. No. Okay, so you can see there's like testing for collision. It's also testing like the player movement and the input, and some of the scene changes. And in less than 10 seconds, we are running 19 tests, which is okay. We also have another example here. Why isn't this moving? Sorry. Okay. Not this one. Okay, now, so this other example is for Gato, which is a set of accessibility tools and demos that we're going to release soon. And you can see that the character moves, there's part of the dialogue system, but most of the tests, they look like great because they don't even have a camera. So these tests are much lower level. And you can see that it runs 73 tests in less than 9 seconds, which is better than the last one. Sorry, because this is not working. Okay. Okay, so yeah, there's like a bunch of test runners that you can use. The tests that you just saw were written in GAT, the option on the top left corner. But if you're working on C#, you definitely want to check Godot test by the Chickensoft team, or you can even write your own if you want. And now we're going to talk about more test types. But before that, we need to understand when to write a test. So we don't need to test everything. That's the first thing that I want to make clear. So we need to test specific issues. We first need to find an issue and then cover it with a test, because otherwise we're just going to write tests that don't make sense. And remember that the goal for this automated test is not like preventing something from breaking. It's like to know when something is broken, right? And there's also this myth of reaching 100% coverage. Trust me, it's not useful, and it doesn't make sense to try to get that. So yeah, the first test that I'm going to talk about is the screenshot test, also known as the snapshot test. And basically, you just take screenshots of your game and you compare them to see the differences, right? So you just open scenes from the game, take a bunch of screenshots, and that is your base screenshots, the original screenshot that we can see here. Then you make changes on the code, and then you run the test again, generating a second set of screenshots. And then you find the difference. You can see that there's a fifth item that maybe we don't want to have in here. So this is something that you could detect with that. But if you automate this, if you make this like generating a div, for instance, you can also see that there's the fourth item was a little bit like offset to the right, which is maybe it was not obvious when you first saw the image. What can you use this for? Basically for UI testing, for texture checks, and also like if you're writing a shader that needs to have like keep compatibility between different versions, you can also use this to test it, right? So you have a square, you render the shader, and you take a screenshot. Again, like this is super fast. You are just opening scenes, capturing the viewport texture, and then you close the scene and move on to the next one. So this runs super fast. This is actually an open source plugin. It's MIT licensed. You can check it, or we would love for people to extend it if you want. And we're talking with Mike Scholz, the maintainer of GDUnit 4, to integrate it with GDUnit 4. So maybe like more information soon, hopefully. I'll leave the QR on the top right corner of the slide if you want to check it, but there's also a slide at the end of the talk where you can get this and more information. So the next type of test is the performance test, or the benchmark, and this is basically, like the name implies, it measures the performance of our project. So you can use it for game levels, for assets, for whatever you want. The main idea is that you have, like, imagine you have a function that spawns a cube. You execute this function and you measure how long it took for this function to finish, right? And then you do this like 10 times and 100 times and 1,000 times. And basically you measure, like you do this daily until you generate a graph like this one. I didn't expect the video to take this long to load. And so yeah, so you generate a graph like this one. And this is an example that actually comes from the engine. Like the Godot has its own benchmark, and you can check it in the URL. What we would expect is we would see a line like the right side of the graph, so something that doesn't move very much. But you can see on the left side that there was like a huge spike for creating rigid bodies. And this is not telling you why the rigid bodies are like broken, but it's telling you that something's happening, so you need to check it. And yeah, like what can you use this for? Like maybe to track the resource usage for a level during development. So you just open the level, you measure the FPS for 10 seconds, and then like store the value and generate the graph, right? There's also, like, you can use it for like preventing commonly repeated objects from causing trouble. So you can, like, if you imagine bullets in a bullet hell, it could be an example. I don't know if you're aware of this. I know some people are aware of it because I saw them laugh. There was a problem with the City Skylines 2 release because allegedly the NPCs had like super detailed teeth meshes. And I don't know if you can see any NPC on the left screenshot, but I guess it doesn't make a lot of sense to have these detailed teeth if you're not going to see NPCs, right? So yeah. Moving on, we have been focusing on integration tests so far, but let's check some of the other types of tests. Like, let's check the static tests, which are some of my favorites. The main characteristic of this test is that they don't run the game code. They just like open the files and read them and make checks based on that. And I love them because they are very useful and they are almost free to both to write and to run. They are super fast. As an example, if you are a programmer and you have seen compilation errors or you have a linter, those are static checks. They might not feel like tests to you, but a check is a test because it's warning you when something is broken before you push it to the main branch, right? But another example that you can write yourself is that, for example, the screenshot here is the script that checks the file naming. So we agreed that we want to use a snake case for the files in our project, but I came from Java and I kept using camel case. So I made a Python script that checked that for me and set it on a Git hook so that it runs automatically, and it's warning me of that. I also have an example of on a company that I was working on for an Android application. We had an issue when we enabled a setting on a manifest file, which is the kind of like an Android setting file. One of the features in the application would stop working for some magical reason that we didn't understand. So what our fix was that we didn't enable that feature, right? The problem is that we knew that in my team, but then another team made the same mistake, and then another team made the same mistake. So in the end, what we decided is that we would write a very small static check that whenever the setting was set up, it would throw an error saying, hey, please don't enable this, otherwise this feature will break, basically. So that's another use case that you can have. And moving on to the other extreme of the trophy model, we have the smoke test, which is a kind of system test. This is actually quite funny because the name comes from electronic engineering. And you can imagine, like, if you're building a circuit and you want to try it and you plug the power on and then you see smoke come out of it, it's a bad sign. Maybe you don't know why it's happening, but you know that something is definitely wrong, right? And how does this look in video games? So you can just have a script that opens the scenes of your game and like parses the warnings and errors, and then you generate a summary of this. We have a script that sends the results to our Discord server, so that we have this running nightly and we can get the results very quickly. And this is very useful. Like if you have like different references, like you have scene A that uses scene B, so let's skip these names. Like if you have a player that is using an inventory and you make changes on the inventory, but the player, you don't update how you are calling the inventory on the player scene. So you will not find the issue until you open the player, right? So this would tell you before you open the player scene that something is broken. Okay, so another quick summary. We have the write test, not too many, mostly integration phrase by Guillermo Rauch. Then we test for specific issues. Then we first find an issue, and then we cover with the test that more adequately test the issue that we found. And remember that the goal is to know when something is broken, not to prevent it from breaking, right? And okay, so far we've been talking about how to run automated tests, but we keep running them like pressing a button manually, I mean. So now let's see why that is an error and how to fix it by automation. Like, let's start with a hypothetical scenario. Like, who will make the more consistent coffee? And I'm not talking who will make the best coffee, just which one will be more consistent. Pablo, college students that brews 1 liter every 2 or 3 months whenever he has to cram for exams and buys whatever coffee the supermarket has, or a coffee pod machine with one of those pods that only work on that specific machine. I'm not giving names, not free advertisement. I hope that you say the machine, because otherwise you're in for a surprise. Basically, a manual process is a process that will eventually fail on a long enough span of time. You can be interrupted, you could forget a step, you could make a mistake. We're human after all. Like, you could even like have things happening that don't come from you. So you could have a blue screen or like a power outage on your blog, or maybe like program updates and it doesn't work anymore. Like if you're on Windows, I'm sorry for you, move on to Linux. But yeah, so the idea is that we should avoid manual processes, or at the very least, we should make containment plans, like having a checklist or redundancy. And okay, what processes can be automated? So first of all, running tests. We've been talking about this before on the second part. But you could also automate building your game and releasing it. Like if you imagine you're making a game for Windows, Mac, and Linux, that's 3 platforms, and you realize that the release has a bug, so you have to make a hotfix. But because you are so stressed, when you make the hotfix, you make another mistake. So you have to make a second hotfix. You're looking at 9 different builds and 9 different releases. So if you have this automated, it's just like pressing a button 3 times. But if you have to do this manually, it's a lot of work and you can make mistakes, right? I will also recommend, like, if there's a task that only one person in the team knows how to do, you should look into automating it. I have an anecdote of a team that brought a game to an indie development fair, and they basically realized when they were already there, they paid for the stand, they paid for the hotel, for the flight, everything, that the game was not working. So for the 3 days of duration of the fair, they couldn't show the game for 1.5 days, which is terrible. And they were looking for a publisher, and they could only show a looping gameplay video, right? So the way to avoid that is to automate that. You can do this with something called continuous integration environment. So this is basically, continuous integration is a philosophy that says that you have to make better quality things. You have to iterate faster and to release faster to the real players and users. And that means like having smaller branches, and yeah, like releasing frequently. And continuous integration environment is basically a tool to allow that. It allows you to run scripts in response to, like, whenever you push a commit, or when you merge a pull request, or like every X amount of time with a cron job, or maybe even with a press of a button. And what this does is that it puts automation on the reach for the whole team, and that allows everyone to iterate faster and more consistently, right? The Discord message with the smoke test that you saw earlier, we have that running on a CI environment. And here's where Godot shines with it outcompetes everyone. Like, if you check Unity, this is from a project from a friend of mine, Gerard Gascon. This is a jam game that he made in Unity, and like, it's a super small project. He tried to optimize it as much as possible. Like, he removed part of Unity that he didn't need, and like, he's using a cache so that he doesn't have to redo like building steps. And even with all this optimization, he still needs like 14 minutes to run the test and to generate the build for the game, right? And this is a jam game because when he tried with his like commercial project, which has like Windows, Linux, and macOS like builds, he couldn't make it to work because the runners, basically the machines that were running this automation were running out of memory. Okay, so, and you can see the number there. It's like over 30 minutes. It's a long time. And the thing with Godot is that just 2 minutes, and we generated the build for Linux and Windows. And this one is not doing the testing like the previous one was, but even with the testing, it would take, like you saw the testing running 10 seconds or something like that. So it would be super fast, like a maximum of 3 minutes in this example. So yeah, Godot is that fast in comparison. I would love to like explain how to do this. It's basically a text file like the one on the left. And this is an example that we have for like jam games. It's making a web build for a small Godot game and publishing it to itch.io. There's a QR code with this example and like a link to a blog post where we explain how to set this up. But if you want to do this, you need to know a little bit about GitHub Actions and Docker. Not a lot, but just know what they are and check the documentation for how to use that. But yeah, like I don't have a lot of time, so I'm just gonna go over very quickly. Like the first part is defining when this workflow runs. Then we have the data, then the steps to run. And the steps to run are also super simple. Like you can see, the first one is just downloading the project files. Then we set up Godot, which is just creating a folder and moving a file into it. And then we generate the build with a single line and then upload it to itch.io with Butler. So it's another single line on the terminal. Word of warning, since you are using somebody else's computer, that means that you're just using their hardware, their electricity, their internet connection. It costs money, right? So this table is just an example of some free plans that you have available. There are more platforms that you can use. But basically, while GitHub is okay for most projects, for Godot, like if you have 1,000 minutes per month for free, and the build takes 2 minutes to run, it's like super generous. But if you need more than that, Circle CI doubles what GitHub is offering. And if you need more space to store the builds for your games, like I think that you need to send an email to the itch.io team. But even then, when they give you access to the 30 gigabyte limit, and you can upload your like very heavy games to their platform for free. And the good thing is that you can mix and match these. Like you can host your repo on GitHub, and you can run the CI on Circle CI, and store the builds on itch.io. And so yeah, you can do whatever you want with this. And okay, so very quick summary of the whole talk this time. We learned that the objective of QA is to find defects as soon as possible. In order to do that, we test and iterate the processes we have to achieve this continuous integration, continuous improvement, sorry. And then we write automated tests, not too many, and mostly integration. And in order to do that, we test specific issues. We first find the issue, and then we cover it with the most adequate test for that issue in particular. Remember that the goal is to know when something is broken, not to prevent from breaking something. You need to be able to make changes to your project. And the last but not least is we try to avoid human errors and bottlenecks with automation. So that's all from my part. The slides and like the code examples and other links are available in this QR link here. And yeah, like again, we are free for hire if you need help with this, or if you have a project that you need someone to work on. So yeah, that's it. Thank you. Any questions?
Yeah, hi, thanks for the talk. So in games, there are many moving parts, and there are parts that interact with each other. So how do you write tests in situations where, for example, you have you are attacking an enemy, and in a separate file, in a separate system, you have damage calculations. Like the test needs to know how much damage the attack is supposed to do, but you have to either manually calculate it to define the test, to say that it deals 12 damage, or you are testing the damaging function. But if the function is broken, it will give you the wrong result. So how do you approach it, where the test has to do something and it has to be verified either by hand, or it has to be written every time you do a balance patch or change something?
Okay, so there's a strategy for this called divide and conquer. So basically, what you're defining here has like multiple of those units. You have a player, you have an enemy, or like let's call them like game entities, because it could be an NPC attacking another NPC, right? So you have entities and you have the damage system, like if you already have this split and you have a system that calculates how much damage it does, you can test that system separately. So maybe like depending on the API, the function that you define for that system, you could test that like okay, so imagine you have a function that receives the entity and the weapon it's using and its strength stat or something like that, all the different data that you need. You test that function in isolation, and then you test that the player, whenever the player is attacking a monster, it's calling that function, right? So you don't need to test the whole thing. You can just like divide it into pieces and like make the tiniest assertions possible, like make the tiniest changes that you can on the system, and then like check that those are working.
Thank you.
Thank you.
Thank you for the talk. I was interested in in reproducing bugs, because sometimes I don't know in advance where we'll have issues, and it's difficult for me to cover all the cases in advance. So many times I had a bug that happens because I press an input at a very specific frame, typically at the end of an animation. And to reproduce it, I had to write integration tests in Gut, where I would test a range, dynamic range of parameters, waiting for 5, 6, 7 frames. It would take a lot of time to reproduce. So I had the idea I got from a AAA company, which was to register all the player inputs to reproduce the same situation. So it doesn't work in the long term because the gameplay rules may change, but at least just for that day I would be able to reproduce exactly the same thing. So I don't know if you know about add-ons, or have you tried yourself to implement that kind of stuff, which is more to create very specific temporary integration tests, but that are very useful to fix a specific bug.
Mm-hmm. So in this particular case, as you mentioned, if you record the player input and then you play it back, it might work for some time until something in the system changes and the timing is not right anymore, and then it stops working and you have to re-record the inputs again, which is in my opinion, it's not sustainable. But the thing here is, again, it's another case of divide and conquer. So you might have different systems here that are working together, and it's very important to understand when one system is calling another one, and when you have to it's very orchestrated. You need to deep dive into your code and understand the different events going on. What I'd recommend here is that instead of waiting for a specific amount of time, or instead of replaying input, we have a super advantage with Godot. It's that the event system, the signals, they are very integrated with the language itself. So it's very simple to define signals in our systems. I don't know what were you working on, but for the damage system that we had before, maybe we could have signals for when a player starts an attack, for when the attack hits the enemy, and the damage system is going to respond to those things, right? And then maybe the damage system could have its own signals, whenever new damage to the player is made, or whenever a new damage to a monster is made, we could have signals that later maybe the team uses for effects or for whatever, but that we can also use for the tests themselves, so that we wait until the system detects that it's time to do something, right? And then we hook onto that signal and we wait for that signal, and then we execute our code for that. So that's one of the options that we have.
Yeah, thank you.
Thank you.
Hey, thanks for the talk. So I wanted to ask, when you were talking about shifting left and kind of testing as you develop, do you find that it actually changes the kind of the development patterns and how you write the code itself? And what is your advice to, what should we think about when writing the code to make it easier to test?
In our team, for example, we have the brainstorm, which we historically we had a lot of trouble with that, but we made some changes based on that, and we compressed the time it takes us to work on a brainstorm to find a new idea for a project into just 2 hours, which is super good for our team. But also for writing code, we started making jump games, and we first followed this I don't know if it's a Unity pattern where you have an assets folder and then you have like a scripts folder and then like a texture folder, and like everything is split like that. But we moved on to a module-based architecture based on this. Like the main idea here is that QA is not exactly just writing code. Like you can just talk with people. Communication is super important, and like we decided like that pattern where we have like a texture folder and music folder and stuff like that, it doesn't work for us. We need to, we work better with a module-based system. So we have a module for like the dialogue system, and that dialogue system has textures that the dialogue UI uses. It has the UI for the dialogue. It has the like model classes for the dialogue, and it's everything like encapsulated in that module, right? So that's like another way in which it helped us like define how we work in our team. You could also see the difference in the it's not very obvious, but when I showed you the two integration test runs between Meetable and Godot, basically the first one you could see the game like it would look. It was like very close to what the final user would see. So it was like a very high level test. It was very close to a system test. And that's because the game was, let's say that we wrote code first and we ask questions later. So it's not a very, very good code. It's very spaghetti and it's very difficult to test. So we had to make very high level tests because we couldn't go into the low level. And for the next project, we decide, okay, maybe for the big like core modules in our game, we can take a little bit of time. Actually, some of the dialogue system that I was mentioning before, we made that using TDD, so like test-driven development. So we first wrote the test, and then we wrote the code that implemented the check that the test was making. And yeah, like all of those came from feedback that we gathered ourselves in the team with this post-mortem and the retrospective meetings. So like, does this answer the question? Yeah. Okay, thank you.
Hi, thank you for the talk. You mentioned that, so the way to think about testing is that the point is not to prevent bugs, but to know when there is a bug. And from the other questions I've heard, like for when you're testing specific situations where lots of things are interacting with each other, would it not be also maybe, because you mentioned divide and conquer, because that's usually how I would think about testing, just like test every single step in this giant process. So I know every building block is working. But with this new way you mentioned of like test to know when there's a bug, you could, if I use, for example, the example of attacking an enemy, simply just test the end result you want to expect. For example, an enemy has 100 health, the weapon of the player does 25 damage. Just do the only simple calculation, divide the health by 25. Okay, so 4 hits, and then the test simply hits the enemy 4 times, and then check if it dies. And then you kind of assume everything between is working, and if it doesn't die, then something must be wrong in that process. Is that also then, with your line of thinking with tests, is that a good approach?
I think it would depend on the project. From what you said, I think that maybe it could work. Like again, this is like in engineering, there are no right answers for everything, right? So you have to think about, it's always a trade-off. Like in this case, you're trading off like execution time and like how much it takes you to write the game. The test itself. Like it's going to be a test that is faster to write. It's going to be easier for you, the developer. But what you're trading off in this case is that it's not so granular, so it doesn't tell you as much information, right? It tells you that something in this like period where you're hitting the enemy 4 times, it's not working if it fails, right? But it's not telling you what is failing. And the main difference here is that if you like split this, like maybe you have just checking one of the attacks and checking that it reduces 25% of the damage, you could have 2 tests, one with a full life and another one with just 25% of life. for the enemy, and then instead of like running all these like 4 hits like simulation, you just run one particular scenario and then you run another particular scenario, and you perform the checks that you want for each of those cases. And it's gonna be like shorter, it's gonna be more resilient, let's say. So that's something that you could do. But both approaches are useful. I think it's better to have tests than not to have them, and it's definitely better than if you were to test all the 4 scenarios, right? Like with 100%, 75, and 50%. That's like we don't need that. So, it's again, it's a trade-off.
Thank you.
Thank you.
Last question.
Thanks for the microman running around.
Thank you.
Question about tests in relation to time. So writing tests, I sometimes have the issue that I have a function of time, like I press a button and I have an animation of the menu popping up and I want to test that this works. Or like in VR, you have gestures and the user has to point at a certain thing for a number of time to activate something. And writing tests, it elongates the test because now it's running for 5 seconds just to like get past this time out. Do you have any recommendations on how to speed this up? Because I haven't found a good pattern like time scale or skipping these animation, but it feels hacky to like implement something in the code just for the test case.
I would say that it shouldn't feel hacky. Like that is something that if it works, it works. And I think it's a really good solution to have like actually what we do in our games is have like a time scale value. And when we are running a test, we set it to 0. So all the animations run instantly. And that is something that happens. Like if you go into the debug settings for Android, they have a setting to like disable animations on the system completely. So I think that it's a good solution. You shouldn't feel bad about that. It's a good solution. And thank you. And I would also like to ask, like, thank you, Eric, for running around with the microphone. Can we have a round of applause for Eric? And I think that was the last question. So thank you all for attending, and I hope that you found it useful. Goodbye.